Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my BEng Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, so the 2019 question on coordinate geometry, the line. Question 2, the diagram shows the line PQ and the line QR. The coordinates of the points are P is 4, 2. Q is 8, 5. And R is 2, 11. Find the slope of PQ. Okay, so for any of these questions, you're in the log tables, page 18, on the coordinate geometry, the line page. So you'll see up the top, they just give an example of a line PQ and they show you how to label the points. X1, Y1, X2, Y2. So for any point, we label it X comma Y, okay? And I remember it as X before Y in the alphabet, X before Y as you label them. So the first point just gets called X1, Y1 because it's your first point, and the second point gets called X2, Y2. So you label the points, and then you figure out which is the right formula to use. So once you get used to this chapter, it's not a bad old question because all the formulas are given to you and there's not too much remembering. So if you're asked for the slope of a line, you tend to use this formula here. And slope is always called M. A length of a line, or the distance between 2 points, we use this big long one here. The midpoint, we use this one. And it's like any other point. So every point is X comma Y. There's your brackets. There's your comma between the points. So it's the midpoint or halfway between whatever 2 points you're looking at. Equation of a line then, 2 formulas. The first one is how to find the equation of a line. So y minus y1, we'll practice loads of that. And then this y is equal to mx plus c. It doesn't get used as much, but does get used. It's where you are given an equation of a line and you need to do some work with it. And then one you may not have seen before, which is the area of a triangle down here. And that's it. This one is on the higher level course, so irrelevant to ordinary level. Okay, so what were we asked for here? We were asked for the slope. Okay, so we're looking for the slope. So in any of these questions, always write down the formula. Because that tells the examiner that at least you know what you're doing, you know what chapter it was, you know what formula you should be using, even if you can't use it, but at least you get the marks for knowing that there is an equation for a slope, and here it is. Okay, then you take the lines. If it's PQ that you're asked for, well then the point P is 4, 2, the point Q is 8, 5. And I label them. So x1, y1 of my first point, x2, y2 of my second point. Like I said, if you forget, like we all do, it shows you here how to label the points. Okay, and then you sub them in. So then slope becomes, instead of y2, I put in this value here, y2. Instead of y1, I put in this value. Instead of x2, I'm putting in 8, and instead of x1, I'm putting in 4. Okay, on your calculator, hit the fraction button, and then I have 5 minus 2 on the top, 8 minus 4 on the bottom, and I'm getting 3/4 as my answer for the slope of PQ. Okay, now the last little check I do is because I tend to make silly mistakes. 8 minus 4, 5 minus 2. Okay, so he looks good. So the last little sanity check I do is I have a look at the line PQ. Okay, now from left to right, so in the direction that I'm drawing it, okay, can you see that's going up a hill? Okay, so slope is a measure of steepness. That's all slope is. How slanty is that line? So from left to right, it's going up a hill. So I am not surprised that that's a positive slope. If I got a slope of RQ, then I would expect it to be a negative slope because it's going down. Okay, so I got a positive answer For that, I'm not sure if the 3/4 is right. This is me now as a student, but I know it's positive. So I have a little bit of faith in my answer. Okay, so that's the slope of PQ. The next question then asks you for find the equation of the line PQ. So back I go to my log tables. An equation is down here. Okay, so to find the equation, it's always the top one. So y minus y1 equals m times x minus x1. Okay, it's the same line that I'm getting the equation of PQ. So to be honest, I wouldn't write the points out again. I'd look up here because they're done already for me. So you're getting an equation. So you see this x and y that sits here, we don't sub anything in for them. Every equation tends to have x's or x's and y's in them. So what do we sub in? Well, we sub in a point, x1, y1. And if I'm finding the equation of the line PQ, there's only one point here, x1, y1. It can be either of the points. Okay, so P or Q works for this. Okay, and then M here is slope. Okay, be careful you don't think M is midpoint because that's what it would feel like it should be, but it's not, it's slope. So that means that anytime you're asked a question to find the equation of a line, you have to find the slope beforehand. Now, some questions are kind, like this one, in that they ask you for the slope first and then they follow it up with the equation. So they're trying to help you do the steps to find the equations of the line. But not all questions are that kind. Some questions go straight for this. Okay, now you might have noticed I also didn't even read the second line. I kind of glanced at it, but I didn't read it. And I often do that. If I'm going to be intimidated by the second line, I tend to just glance at it, but I concentrate on the job in hand, which is find the equation of the line. Okay, so this is the order that they want the answer in. So there's nothing you can really do with that till the end. So when I get to the end, I'll explain that one. So y stays y. I'm going to use p because I've already labeled it as x, x1, y1. So this is p up here. So I'm going to use 4 and 2 again. So y1 is 2. My slope is 3/4 x minus x1. Okay, now you might have changed your slope to 0.75. That's okay. Sometimes it makes more sense to leave it as a fraction, and I'll tell you why. So I'm going to put a line down here, and I'm going to do this bit in 2 ways. And you can decide, do you prefer the way on the left or the way on the right? Okay, so the first thing I might do is just work with the 3/4. Okay, and just multiply them in. So just like in any algebra question, when you have brackets, that means everything in the bracket needs to be multiplied by the 3/4. So this is y minus 2 equals 3/4 by x is 3/4 x. 3/4 by minus 4, I'm popping onto my calculator here. So 3/4 multiply by minus 4, and I'm getting minus 3 for that. Okay, I then need to merge the two numbers. So I tend to bring that minus 2 over this side, or you could plus 2 to both sides, whatever way you've been shown how to do that. But either way, you get y is equal to 3/4 x minus 3, and he becomes a plus 2 when you bring him over. So y is equal to 3/4 x minus 1. Okay, so that's the answer to the equation. I don't have it in this form yet, so let's do that. So they want the x's first. So let's put down 3/4 x. Then they want the y's. Well, the y is on the other side, so I'm going to bring him around into here. And when he crosses over the equals to sign, it changes sign. So he's minus y. Okay, and then the minus 1 stays there. The c is just a number, equals 0. So that is in the form ax plus by plus c is equal to 0. Okay, not that you need to know, but that's your a is 3/4, b is minus 1, c is -1. So those ABCs that appear there are just numbers that may be in front of X, number that may be in front of Y, C is a number. Okay, so B is not 0, it's -1. If there's no number in front of it, it's -1. Okay, so what am I on about when I say there's another way of doing it? Well, you see the way there's a fraction in this one? We've got 3/4. Okay, so okay. So maybe we don't like fractions too much, and maybe we'd like to get rid of the fraction. Okay, well, if I multiply that side by 4, it's gone off the page. Let me move in a little bit. If I multiply that side by 4, okay, well, the first thing is what I do to one side, I have to do to the other. So I have to multiply the left by 4. But 4 on the bottom of a fraction cancels with the 4 on the top. So look at my right-hand side now has become 3 times x minus 4. So that's beautiful. There's no fraction. It's definitely easier. So what has happened to the right? Well, because I multiplied, what has happened to the left? Because I multiplied the right-hand side by 4, I have to do it to the left, okay? And that's to maintain balance in the equation and make sure that the equation overall doesn't change. So if you think about the equals as if you think about an equation as a weighing scales, where equal is the balance, as long as you make one side 4 times bigger, which is what we did when we multiplied by 4, that's perfectly okay as long as you make the other side 4 times bigger. Okay, so you describe it then as you maintain balance of that equation. Okay, so what have you done? Well, you've got rid of the fractions, but you've created another little job in here where you have to multiply y minus 2 by 4. Okay, the other way people remember that is that, let me get a bit of an orange color or something. See that 4 that's there? That comes up. Okay, so in other words, the 4 that was there comes up here. So they don't know technically why, but they know that it does. And that's perfectly okay if that's the way your brain works and that's how you choose to remember it. So the number on the bottom comes up to the side on the left. And then you go 4 by y is 4y, 4 by minus 2 is minus 8, 3 by x is 3x, 3 by minus 4 is minus 12. Okay, and just like before, I would bring over the minus 8 on this side, or plus 8 to both sides, whichever way you've been shown how to do that, so that you end up getting 4y being equal to 3x minus 12 plus 8, or 4y is equal to 3x minus 4. Okay, and then let's compare. I still haven't written it in the right form, but I want to compare this one here now with this one here. Okay, so what's happening? Well, can you see that basically this one is 4 times bigger? And of course it is, because we multiplied it by 4. So in other words, y is now 4y. 3/4, if you multiply that by 4, you get 3. And minus 1 by 4 is minus 4. So technically, these are the exact same equation. One is just 4 times bigger. But if I solve that for x or y, I will get the same answer because each component of it is exactly 4 times bigger. Okay, so the last job I have to do on this one then is to write it in the order ax plus by plus c is equal to 0. Okay, can I just add that if they didn't ask me for a particular order, like they did here, if that line wasn't there at all, I would leave my answer like this. Okay, but they did ask me for a particular order. They want the x's first. Okay, then we want the y's. Okay, and that's that part of the question done. Okay, so write down the slope of any line perpendicular to PQ. Okay, so let's come up here again and let's find our slope for PQ. So slope of PQ, we got to be 3/4. Okay, so let's think. There's two very important things you have got to know about lines and slopes as part of your Leaving Cert course. So parallel lines, you won't be too surprised to hear that parallel lines have equal slopes. Okay, perpendicular lines though, so if I draw a set of perpendicular lines, okay, so these are the ones that have the 90-degree angles between them. So you can see straight away there's no way they have equal slopes. They're going in two different directions. So if we look at this one going up here, that has a positive slope. We look at this one from left to right, that has a negative slope. So even the signs of them aren't even the same. But there is an inherent relationship between them, because if I turn that, if it'll be kind enough to let me, if I turn him or rotate him, that 90-degree angle is going to be maintained. So the two lines have to turn at the same time to be able to maintain this 90-degree angle. So there has to be a relationship in slopes or slants then between the two lines. And the relationship is as such. Okay, if I take this one to have a slope of 3/4, then this one, you turn it upside down and you change the sign. Okay, so any line perpendicular to a line with a slope of 3/4 will have a slope of -4/3. So turn it upside down, change the sign. Okay, as another example, if I took lines with a slope of, we'll say this one has a slope of 2, okay, then the line perpendicular to it with my 90-degree angles would have a slope of, well, 2 becomes 2/1. Turn it upside down, change the sign. Okay, so that's how you get your slopes of perpendicular lines. And there's no more to it. It is as easy as that. So the answer to part C then is -4/3. Okay, turn it upside down, change the sign. There is a formula then. So this is the official way of checking it. You didn't need it for this question. You can just turn it or turn it upside down and change the sign. But if I take the slope of one line, which is 3/4, and I take the slope of the line perpendicular to it, which is -4/3, and you put those two into the calculator, you will always get an answer of -1. Okay, so that's just a little bit of theory behind perpendicular lines and their slopes. Okay, so that's that one. So then part D, find the area of the triangle PQR. So PQR as such. Okay, and I'm told to find the area of it. Okay, if we go to the log tables, you can see that we do have a formula, which is a half x1, y2 minus x2, y1. Okay. x1, y2 minus x2, y1. Okay, or you might remember that there is another area of a triangle, which is half the base by the perpendicular height. Okay, that's another one that's in your toolkit from different chapters. Or you can get the area of a triangle from trig as half AB sine C. So as part of your course, there's a lot of formulas for finding the area of a triangle. This one we call from coordinate geometry. This one is from area and volume. And then this one is from trig. Just because this question is in coordinate geometry doesn't mean you have to use this one. If you're asked for the area of a triangle, you can use any of the tools in your toolkit. But what it does normally mean is that you may most likely only have enough data to be able to use this one. Okay, now why can't I use half the base by the perpendicular height? Well, I'm going to use their triangle. So I'm going to put a line down there, and that's not even at the right angle. Okay, so we are told to find the area of this triangle here. Okay, so to do that, you would need a base, and then you would need a perpendicular height to it. Okay, so in other words, if I took my base to be PQ, then I would need to know that QR was perpendicular to it. Now, it looks like it could be, but I don't know for sure. Okay, so I can't assume. I could also use QR as my base, and then I could do half the base by the perpendicular height if I knew QP was perpendicular to that line. So what I'm trying to show you is that you can use any base and the other side is perpendicular to it, but you have to know that that other side is perpendicular to your base. Okay, otherwise you cannot use this one. Now this one we have no angles, so I can't use this one. So that's why I'm saying in many cases you're forced to use a particular formula for the area of a triangle. Okay, so that is the one that I'm going to use. Now, something else I want you to notice in this one is that it only has 2 points, x1, y1, x2, y2. So how do you know which 2 points to use? Because any triangle has 3. We have P, Q, and R. Can I just pick 2? Does it not matter? Is there 2 set ones I should pick? And so on and so forth. Okay, well, it does matter, and it doesn't work if you just pick a random 2. So in other words, if you picked PQ, for example, can you see then that we can see where R is, but there's nothing stopping me forming a triangle like that. And that triangle has a completely different area to PQR. Okay? There's also nothing stopping me forming one out this side. And that has a different area to R. So what I'm trying to show you there is that no, it's not okay just to use 2 points and ignore the third. Okay? But the formula still only has 2. So what you do is you pick any one of the points and you move it to 0, 0. And whatever amount you move that one by, these two have to move the same. So you pin one of the points on the origin, and then we use the other 2. So let me try and explain that. So I'm going to move P for no reason at all, only that it looks like in my head it's closest to the origin, and I tend to use the one closest for no reason. Okay, so P is the point 4, 2, and I'm going to move that to 0, 0. Okay, so what am I doing to the x coordinate to do that? To go from 4 to 0? Well, I'm subtracting 4 off the x value. What am I doing to the y coordinate? To go from 2 to 0? Well, I'm subtracting 2 off the y coordinate. Okay, so in other words, if you can imagine this moving, it's like P is taking 4 steps back in the x direction and down 2 in the y. So what I want to do then is to have R move 4 in the x and back down 2 in the y, and have Q do the same. And if I do that, then I have the same size triangle, one of the angles pinned on 0, 0, and then I can find the area of this triangle, or that's what I'm going to try and do. Okay, so how do we do it? Well, you take Q then, which is 8, 5, and you minus 4 off the x and you minus 2 off the y, so that you end up with 8 minus 4 here to give me 4, and 5 minus 2 over here to give me 3. Okay, we then take Q, we then take R, which is up there at 211, and again we minus 4 off our x, we minus 2 off our y, and we end up getting 2 minus 4 will bring me to minus 2, 11 minus 2 brings me to 9. Okay, and when I have one of the points at 0, 0, and the other two moved at the same amount, well then that becomes my x1, y1. This becomes x2, y2. So this whole thing that we've done here, this moving, is called a translation on your course. So we've translated this triangle from its current location to a new one where one of the vertices, which is a fancy word for corners, is pinned on 0, 0. Okay, and it's these two new points here that we feed into this area of a triangle. Okay, so area is half of x1, which is 4. Always when you have two letters here butted up against each other, that means they're multiplied. So that's why I'm using my brackets. x1, y2 is 9. Yeah, so there's my x1, y2, and then I'm coming back for my x2, y1. So minus x2, y1. Okay, I put all that into my calculator, so a bracket here, so 4 9s are 36, minus 6, so I'm getting half of 42, and I get 21 units squared if I did that right in my head. And that is the area of that triangle. Okay, so just one final point on it before I finish is these two lines here. So that's what we call the modulus, or the absolute value. So no matter what value we got in here, so for example, if we had got minus 42, our answer would still be positive. Okay, so the absolute value of a number means we take the positive answer. The sign is irrelevant in this case. And if you think about area, area is area. It doesn't matter whether it's a positive or negative. So how could you possibly get a negative for it? Well, you will get it if you move that triangle down here into the negative area, okay? Because remember, these are my negative x values and my negative y. So possibly the area of a triangle down there will be minus 42 units, okay, or half of minus 42 units. So, but again, it doesn't matter. It's still the same area of a triangle. So it's just its location is what the minus value means. Okay, but area is area. It's how much space it takes up. So we ignore the minus and we just take the positive. So 21 units squared. And that finishes that 2019 question.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in electronics and self-driving technologies, and from there to the Masters.
Check out the link below for more information.